Hello students, welcome back to Diksha Vedantu English channel for 9th and 10th. I am your chemistry master teacher Ankita. Today we are going to discuss a very important chapter. This repeats in your 11th standard as well, 11th grade. Okay, structure of atom. So this is the foundation class. Let me remind you again. This is the foundation class. Okay, so this is going to be helpful for you to ace your NTSE and NEET exam, JEE. I mean, they wouldn't ask you from these concepts exactly, but foundation is extremely important. The basic concepts are very important. Olympiad exams like KVPY, NTSE, NSTSE, this is very important. Alright, I hope I'm audible and the screen is visible. Let me check once. Yeah. Alright, so yes, I am audible and visible. Hi Abhilasha, hello. Hi, welcome to the class Abhilasha. Is it the first time that you are coming to the live class? I mean, it is the first time I'm seeing, the name. Anyway, a very warm welcome to the class, Diksha Vedantu English, the channel, Abhilasha. Very good evening, very good evening. Please do subscribe to the channel and turn on the notification button, and do not forget to share the videos with your friends so that it will be very useful for them as well. Hi Aftab, hello, welcome to the class Aftab. Yes, the foundation course is going on. That's exactly me. Okay. Yes, making your grade 11 and 12 pathway easy. We are going to get you ready for NEET exam, NSTSE, NTSE and Olympiad exams. Okay, not just that, but this is the foundation. This is very important. You're an UPSC aspirant right now. Okay, that's very nice. All the best. It takes a lot of courage to write UPSC. It takes a lot of courage to prepare for UPSC because it's a laborious process, prelims, mains and interview process. I hope you ace your exam. All the best, Abhilasha. Aftab, you're from CBSE board. That's very nice. Good. Hi Arun. Hello. Welcome to the class, Arun. Both of you, all of you, welcome to the class. Yeah, let's get started then. So on 28th of March, that's day before yesterday, we have discussed about matter in our surroundings, part 1. 29th, part 2 is done already. You can check that out. Okay. And today is 30th and we are going to discuss structure of atom. Let me remind you again. So yes, the basic concepts are from CBSE, but I have taken some deeper concepts because you will have this in your competitive exams. Okay, so the questions are not going to be as simple as your syllabus, in which is prescribed in the CBSE board, by the CBSE board in your high school, that is 8th, 9th and 10th. You need to have a deeper understanding. That's why we are conducting foundation classes. Okay, we are going to give you heads up about the difficult concepts. Okay. Yes, tomorrow, day after tomorrow, we'll be conducting part 2 of the same chapter. Then we'll go on with is matter around us pure. Next, is matter around us pure part 2, and atoms and molecules we'll discuss on 4th and 5th respectively, part 1 and part 2. Okay. Yeah. So today we are going to discuss about structure of atom. First, we'll be discussing about atoms. What are atoms? How subatomic particles are discovered? We know what are subatomic particles. You must have studied this in your for your board exam. If you are in 9th standard or in 10th standard, of course you must have studied this. You have a basic understanding. Okay. If you are new to 9th standard or if you are new to 10th standard, welcome aboard. Okay. We'll discuss in detail. Discovery of subatomic particles, neutron. So we are going to discuss all these part first. Okay. Okay, you are in college and you are going to give UPSC next year. Very good. Is this useful? Aftab, yeah, this is going to be extremely useful. Okay, because you are going to give competitive exams. I mean, almost all of the students, wants to give competitive exams, write competitive exams, because you need to get into good colleges, right? Or if you talk about Olympiad exams, the government is going to give you stipend. The government is going to provide you, the scholarships. Who wouldn't want that? Who wouldn't want money, right? Economical help from government. So financial help from government. So if you are going to give Olympiad exams, be it KVPY or you have NTSE, NSTSE, and if you are in grade 11 or 12, you will be giving after your grade 12 you will be giving NEET exam, JEE exam. For all these competitive exams, foundation is very important. If you don't have a basic understanding of the concept, you won't be able to understand the difficult concepts. Okay, yeah, we'll get started then. Introduction to atom. In the last class, we have discussed about matter. So matter is anything that has mass and occupies some space. It should have volume. And we have discussed about the properties of matter. And while we were discussing about uh, is this for 11th? Aftab, not entirely, okay, but this is the introductory class for 11th. There is a chapter called Structure of Atom in your 11th grade as well. Okay, we'll be introducing you with the important concepts. We'll be making sure that we are going to have a strong foundation for you. Okay, basic concepts very strong. Okay, yeah. So matter is anything that has mass and occupies some space. And there are a couple of properties of matter, as in the particles of matter. These particles of matter are nothing but atoms. Okay, so atoms and molecules are the building blocks of matter. The existence of different kinds of matter around us is due to different types of atoms and molecules present in them. So there are so many different things around us, right? I have a spoon here, and I have a tissue paper here, and there are so many things. There are plastics, and there is watermelon. See here, there are so many things. All these things have different properties. Why? Because they are made up of different types of atoms and molecules. That is why. Okay, so we see minerals, oil, book, copper. All of these things are matter because they have some space, they occupy some space, and they have some mass. So Dalton's atomic theory. Dalton was the first scientist to come up with atomic theory. He had some idea about atoms. What did he say? Elements are made up of very small particles of matter called atoms. Yeah, he's absolutely right. So it doesn't mean that Dalton came up with his first atomic theory. It doesn't mean that he was entirely right. Okay, but it was a great attempt from Dalton. He says that atoms are indivisible, which means that we cannot divide atom further. Atoms can't be divided. Indivisible means it can't be divided. The atoms of an element have the same weight. Okay, if an atom belongs to the same element, for example, iron. Okay, iron atoms will have the same weight, all the iron atoms. The atoms of different elements have different weights. Both of these are correct. It is the atoms of elements that take part in a chemical reaction. This is also right. During a chemical reaction, what happens? Rearrangement happens. So rearrangement with respect to what? Maybe with respect to the atoms or molecules. That is going to happen. The old bonds are going to break and new bonds are going to be formed. The atoms of an element combine in a simple numerical ratio with those of other element to form compound. This is also absolutely right. Only wrong postulate was this one. Atoms are indivisible. No, atoms can be further divided into subatomic particles. So this was proved by other scientists later on in time. Okay. Next, conclusion. What is the conclusion of Dalton's atomic theory? For a long time, it was thought that the atoms are indivisible. This is the drawback, one of the drawbacks. But now we know that atoms are divisible and they have subatomic particles in them. So we know electrons, we have discussed about protons, and we have neutrons as well. And we have something called Higgs boson particles as well. It's not there in your syllabus. You will be studying that in your higher grades if you take up chemistry or physics, Higgs boson particles. But yeah, these are the subatomic particles that we will be discussing in this chapter. Subatomic particles. You must have noticed if a rubber comb in dry hair, the comb attracts small pieces of paper. So this is a very common magic trick that we used to do when we were really young. Right? I have done it. I have shown this to my cousin and she was in awe. Oh, Akka, how did you do this? Right? So it was science. Similarly, then the glass rod attracts the balloon. As we know that an electrically charged object can attract an uncharged object. So electrically charged object can attract an uncharged object. This means that on rubbing with dry hair, comb gets an electric charge, and on rubbing with silk cloth, glass rod gets an electric charge. Until then, it didn't have any charge. It was neutral. Okay. So due to collision, what happens? The charge is formed. The charge generates within the atoms present in the comb and glass rod. So what can we conclude here? These simple experiments tell us that some charged particles are present in an atom, thus the atom is divisible. So there must exist some charged particles, right? Upon rubbing that, upon collision, something formed there, right? So what is it? Atom must have something. So let us recapitulate about subatomic particles of an atom. So we have electron, we have proton, and we have neutron. So the symbol for electron is this. Rather writing electron, electron, electron every time we mention electron, so we make use of this symbol. Okay. Why negative, on the head of E? Because electron carries a negative charge. It is a negatively charged subatomic particle. Proton, it is positively charged subatomic particle. We represent proton by writing P plus. Neutron, so the name itself suggests here, neutron is neutral in nature. It doesn't possess any charge, neither positive nor negative. Okay, so it has a neutral charge, zero charge it has. It is neutral. So now we have a question. Column 1 and column 2, we have few of the things. Electron, proton, atom and neutron. So how are we going to match this? All of you please answer. I can see that 6 students are watching the live and yeah, I need 6 answers. Come on. Give me the answer. We just discussed that. Electron, proton, atom, neutron. Yes. We'll make use of elimination method here. Okay. We know that protons are positively charged. PP. Okay. Positively charged. Neutron is neutral in nature. Okay. We know that B goes to R and D goes to Q. We'll eliminate whichever is not going to suit this. Okay. So what is it? BR. Okay. This holds good. What about this? Yeah, this also holds good. R and S it is saying. What do you mean by R and S? So what is this subatomic particle? Yes, that's also true. Yes. Next, this is also holds good. What about D? Let's see. D goes to Q. It is also a subatomic particle. Q and R. Q and R. Okay. What is it? Not Q and R. Q and S. Q and S. So let's see. Q and S. Yes. Q and S. Yes. Here just Q. Here just S. So we'll eliminate this. What's going to be the answer? It's going to be option C. Okay. We have eliminated this. So option C is the right answer. Why? A is P and S they are saying. P, which means that electron is negatively charged. They are absolutely right. And it is a subatomic particle. That is also right. B is anyway right. Right? Next, atom. What are they saying? Atom Q. Atom is neutral always? Not necessarily. Okay. Yeah, it is neutral. And it can be further divided. There is one more that we need to match. Okay. So, which is the answer? Option C is the right answer. Electrons are negatively charged subatomic particle. Protons are positively charged subatomic particle. Neutrons are neutral in nature and it is also a subatomic particle. Atoms are usually neutral because electrons and protons will be in equal number. Okay. And it can be further divided. Moving forward. According to Dalton's atomic theory, matter consists of indivisible dash molecules, atoms, ions, mixtures. According to Dalton's atomic theory, what will be the answer? Come on, give me the answer, all of you. What's the answer? Matter consists of indivisible atoms. Okay. Next question. Which of the following is not a subatomic particle? Electron, proton, neutron, hydrogen. Which is not a subatomic particle? Electron is a subatomic particle. Yes. Proton is a subatomic particle. Neutron is also a subatomic particle, but not hydrogen. Hydrogen is an element. It is a first element. Okay. Moving forward, we'll discuss the discovery of subatomic particles. The existence of electrons in an atom was shown by J.J. Thomson in the year 1987. Okay, 100 years, 100 years to my birth year. I'm born in 1997, and yeah, he proved the existence of electrons 100 years ago. So 1987. He studied various gases in a glass discharge tube. Discharge tube, what does it contain? It is a glass tube with a very high potential applied to its end at low pressure. So there will be electricity, okay, passing. And yeah, there will be low pressure. The pressure will be very, very low. He passed electricity at high voltage, which is 10,000 volts, through a glass at very low pressure, 0.01 mm of mercury, okay, taken in a discharge tube. He made use of discharge tube, okay, and he studied various gases using this experiment. So what were the observations that he could see? A fluorescent glow was seen on the wall of the glass tube. What is this fluorescent glow? A shiny glow. Okay, a shiny glow, as if somebody is passing a laser light. This glow was due to the bombardment of glass by a certain kind of rays emerging from cathode. Cathode is the negative electrode, anode is the positive electrode. Okay, so there were various gases that were taken inside the gas discharge tube. Okay, and what was happening there? There were some rays that were given out. Okay, these rays travel until they strike the anode, which means it is moving towards the positive electrode. So if something is attracted towards the positive positive charge, it must be a negative charge. It must carry a negative charge. Right, so these rays are called cathode rays. Why? Because these were emerging from the cathode. That's why, as they emerge from the cathode. So this is the experimental setup. Okay, we have a cathode, we have an anode, we have a vacuum pipe, and we have a discharge tube. Okay, and there is power source, and there will be a couple of gases. That's he handpicked the gases. It was not like random gases will be filled in that and it's made to the experiment is conducted. It's not like that. Okay, he took specific gases there. So cathode ray consists of small negatively charged particles called electrons. These cathode rays were later named as electrons. Okay, and Thomson explained the formation of cathode rays as follows. Gas taken in tube consists of atoms. Absolutely, air is a matter, gas is a matter, right? So matter consists of atoms, and atoms contain electrons. When high electrical voltage is applied, the electrical energy pushes out some of the electrons from the atoms of the gas. It kicked out some of the electrons from the atoms of the gas. These fast moving electrons form cathode rays. These are going to form cathode rays. So what can we conclude about it? The electron is a negatively charged particle found in atoms of all the elements. So electron is a negatively charged particle found in all atoms. Okay, in atoms of all the elements. So electrons are present in all the atoms. So what are the characteristics of electrons here? The mass charge is given here. The mass, it has a very minute mass. Okay, it doesn't have a significant mass. Okay, relative mass is 1/1837 atomic mass unit. Atomic mass unit, what is atomic mass unit? 1 AMU. We have discussed this in the part 1, matter in our surrounding. Okay, 1/12 the mass of carbon 12 atom. This is 1 atomic mass unit. Imagine this number, it is very small. So absolute mass will be 9.109 into 10 raised to minus 31 kg. Relative charge is -1 and absolute charge is -1.6 into 10 raised to minus 19 coulomb. And charge to mass ratio of electron. So just dividing this 1.6 into 10 raised to minus 19 by 9.109 into 10 raised to minus 31. What is the value? It is 1.75 into 10 raised to 11 coulomb per kg. And electron is represented by the symbol E minus. Alright. Moving forward to the properties of cathode rays. We conducted, J.J. Thomson conducted the experiment, and what were the properties? cathode rays travel in a straight line. There is no zigzag or wavy motion. They travel in a straight line. Okay. If a solid object is placed in the path of cathode rays, a sharp shadow of the object is formed on the wall opposite to the cathode, which means that it is traveling in a straight line. What are the heating effects then? Cathode rays heat the object on which they fall due to transfer of kinetic energy to the object. Okay, it causes heating effect. Alright. Next, cathode rays consist of material particles. If a light paddle wheel is placed between the electrodes, it starts rotating. Okay, it has kinetic energy, of course. So, when there is a light paddle wheel that is placed between the electrodes, positive electrode and the negative electrode, that is going to start rotating. Okay, and on striking against walls of the discharge tube, cathode rays produce greenish fluorescence. They have the tendency to produce greenish fluorescence, green light. Alright, these are the properties of cathode rays. And not just that, what is the effect of magnetic field on cathode rays then? When magnetic field is applied perpendicular to the path of the cathode rays, they get deflected in the direction expected for negative particles. So perpendicular means this one. Okay, so when we apply magnetic field like this, so the cathode is going like this, so the magnet is placed like this. Right? What happened? The rays deflected. They change the direction of their, travel. Okay. So they get deflected in the direction expected for negative particles. Whenever we have negative particles, when we subject the negative particle to magnetic field, perpendicular subjection, so the negative particles, change or deflect and move in a certain way. The same thing was observed for cathode rays, which means that this is negatively charged. Effect of electric field. When an electric field is applied to a stream of cathode rays, they get deflected towards positive plate of the electric field. Positive plate means negative things are going to attracted towards the positive things. Negative charge attracts towards positive, or south pole attacks north pole. That's how it works, right? So here this cathode rays deflected towards positive plate, indicating that it is negatively charged. Alright. Next, Millikan's oil drop experiment. Mind you guys, these are not there in your CBSE board. Yeah, until here it is there in your CBSE board. Okay, after this, properties of cathode rays. So it is out of syllabus. Out of syllabus as in this is important for your higher grades, but not for your 9th grade. Okay, if you are writing board exam, this is not there for you. Okay, do not concentrate on these things. So I'm really hoping that you have completed your 10th or 9th standard and you are moving towards your grade 11 or 12. That's why we are conducting this bridge course or foundation course. We are including few more concepts into the classes. Okay, yeah. So Millikan's drop experiment. What is Millikan's drop experiment? R.A. Millikan was a scientist. Okay, he conducted this experiment, so it is named after him. With the help of his experiment, he determined the charge on the electron. How? So this is the Millikan drop experiment apparatus. So what did he take? He took a negatively charged plate and he took a microscope in order to observe the subatomic particle, and he took a positively charged plate and he took an atomizer and source of ionizing radiation. Source must be there, right? Cathode ray source must be there. He took it. So what will be happening here? So the charge on each electron found by Millikan was equal to minus 1.6 into 10 raised to minus 19. This experiment is not in detail. Okay, this experiment is not in detail for you. Okay, you wouldn't study in detail about this experiment. Don't worry. Yeah. So specific charge E by M on electron is found by J.J. Thomson. Okay, so yes, charge by the mass it is equal to 1.75 into 10 raised to 11 coulomb per kg. Okay. Yes, Abhilasha. Please tell me. On combining these results, so what will happen? See here, ME is equal to 9.10 into 10 raised to minus 31 kg. What is this then? This is the mass of electron. Okay, this is the mass of electron. Moving forward, discovery of subatomic particle. This is the second subatomic particle which was discovered by Ernst Goldstein, E. Goldstein. Okay, proton. So we have discovered, we have studied about the discovery of electron. Now it's time for us to study about the discovery of protons. So he passed electricity at high voltage of about 10,000 volts through a gas at very low pressure of about 0.01 mm of mercury taken in the discharge tube. The experimental setup was almost the same, but there is some difference. Okay, he also takes gas discharge tube. Okay, so streams of heavy particles were given out by the electrode. So these streams of particles are known as anode rays or canal rays. Anode rays consist of positively charged particles called protons. So what did he take? See here, what is the difference here? There is a perforated cathode. There is a perforated cathode. So what do you mean by perforated cathode? Perforated cathode is nothing but the cathode which has holes. Okay, that is perforated cathode. So the mass and charge of anode ray particles depend on the nature of the gas taken in the discharge tube. So whichever gas that is taken inside the discharge tube, so the mass and the charge of the anode ray is going to depend on the nature of the gas. If you take helium, the mass and charge of the anode ray is going to be different. If you take oxygen, it's going to be different. Okay, so different gases give different types of anode rays which contain positively charged particles having different masses and different charges. It entirely depends on the nature of the gas that is taken. So hydrogen gas is the lightest gas. We all know that because the atomic number of hydrogen is 1. So the positive particles obtained from hydrogen gas are the lightest and have the smallest charge, just +1. Okay, anode rays obtained from hydrogen gas are made of same type of positive particles. These particles are called protons. So this is how he discovered protons. Thus, anode rays obtained from hydrogen gas consist of protons. A proton is formed by removal of an electron from an hydrogen atom. If you remove an electron from hydrogen atom, that is itself proton. Okay, that is itself proton. So what is the mass and charge of the proton? So mass is significantly high when compared to electrons. Electrons are like feathers. So the mass of the electron can be ignored. It's negligible. They are very, very, very light in weight. But mass of the proton cannot be ignored. The relative mass is 1 atomic mass unit. Absolute mass is 1.673 into 10 raised to minus 27 kg. Relative charge is +1. In case of electron, it was -1. Absolute charge is +1.6 into 10 raised to minus 19 coulomb. For electron, it was -1.6 into 10 raised to minus 19 coulomb. And the proton is represented by the symbol P+. P+. Okay. Yes. So this is also how we are going to write. Alright. Moving forward, so properties of anode rays. We have discussed about properties of cathode rays. Now it's time for us to discuss about properties of anode rays. Okay, this is out of your syllabus. For CBSE, if you are giving, you are writing your final exam, you don't need to study about this. Read about this. Okay, I'll write here anyway. Out of syllabus. Yeah. So anode rays travel in straight lines. Anode rays consist of material particles. And anode rays are deflected by electric field towards negatively charged plate, which means that they are positive in nature. When magnetic field is applied in a direction perpendicular to the path of anode rays, they get deflected towards negatively charged plate. Okay, this indicates that these are positively charged. These are positively charged. Which of the statement is correct about proton? Proton is nucleus of deuterium. Proton is alpha particle. Proton is ionized hydrogen molecule. Proton is ionized hydrogen atom. Hydrogen molecule. So when you say hydrogen molecule, it is H2, guys. Hydrogen molecule, because hydrogen is a diatomic molecule. Okay. Diatom means, so one molecule of hydrogen consists of 2 atoms of hydrogen. So what will be the answer? Give me the answer. Yeah. What is the answer? It is option D. Proton is ionized hydrogen atom. We have discussed that if we remove electron from the hydrogen, it is nothing but the proton. Why? Because hydrogen atom has only one proton, one electron, right? So if you remove that electron, it is itself proton. Okay, proton is ionized hydrogen atom, that is H plus. It contains only protons and no neutrons or electrons. H plus contains only protons, no neutrons or no electrons. Moving on, which of the following statement is incorrect for cathode rays? Yes. What is the answer? Option B is the right answer. Their nature depends upon the nature of gas present in discharge tube. Okay, so yes, the nature of cathode rays. Cathode rays are nothing but, what are cathode rays? These are electrons. Is irrespective or independent of the nature of gas present in discharge tube. Alright, now moving forward. Specific charge E by m value of proton is dash less than E by m value of electron, equal to the value of electron, greater than value of electron, cannot be determined. Do it. We already know the charge and mass of the proton. What will be the answer? It is actually less than that of the E by m value of electron. Specific charge is less than. Okay. The magnitude of charge is same for both proton and electron. The mass of the proton is about 1837 times the mass of the electron. See, that's why the mass of the electron can be neglected. It is very, very, very small. That's why. Okay. Next, discovery of subatomic particles, neutron. So, how did they discover neutron? So, it was discovered by who? Yeah. Who discovered neutron? It was James Chadwick. Okay. So, James Chadwick discovered neutron. Yeah. So, after the discovery of electrons and protons, scientists performed experiments to determine the exact mass present in an atom. However, for any element, mass was not found to be much different than the expected mass, except for hydrogen. Because hydrogen doesn't have any neutron. Hydrogen doesn't have any neutron. Okay. So let's understand this. Example, hydrogen and helium. Hydrogen molecule. So what is there in hydrogen nucleus? It's just one proton, right? And one electron will be revolving around here. Okay. In case of helium nucleus, so there will be two protons in the nucleus of the helium. So number of positive charges present inside the nucleus corresponds to the number of protons. So each proton has 1 unit mass. We know that, right? The mass of the proton is 1 atomic mass unit. So therefore, the mass of an atom was calculated from the number of protons present in the nucleus, because electrons have negligible mass. We can ignore the mass of the electron. Alright, so mass of helium should be twice the mass of hydrogen atom, but the mass of helium is 4 times the mass of hydrogen. Of course, hydrogen atom doesn't have any neutron, but helium does, right? Helium has 2 protons plus two neutrons. Okay, 2 neutrons in its nucleus. So it was not matching. They couldn't account for it. So this led to the idea that there must be something else inside the nucleus, okay, which is contributing to the mass, which is contributing to the weight, right? So these particles should be neutral but should have considerable mass. So in the year 1932, James Chadwick performed a scattering experiment. Okay, so he bombarded some light element like beryllium with fast moving alpha particles. Alpha particles are nothing but helium nuclei. Okay, so alpha scattering experiment it is called. So he found that some new particles were emitted which carried no charge. These are nothing but neutrons. So these, that is, they were neutral but had a mass nearly equal to that of proton. So this is how we concluded that. So mass of the mass of the neutron is almost equal to the mass of the proton, but the charge is zero. They do not have any charge, neither positive nor negative. Okay, mass of helium is equal to 4 times the mass of hydrogen. So this way discovery of neutron took place. Atoms of all the elements contain neutrons except hydrogen atom. Hydrogen atom doesn't contain any neutron. Okay. So what are the characteristics of neutron now? Relative mass is almost equal to that of relative mass of the proton. Okay, so absolute mass is also going to be almost same. Relative charge is 0. Absolute charge is also 0. Okay, so this is how we are going to represent neutron. On top, so on the head we represent 1. Bottom, that's subscript 0. Okay, 1 and 0. Next question. Consider the following statements. Neutrons have a neutral charge with less mass than the proton. Neutrons have an electric charge. Neutrons have a neutral charge with almost the same mass as the proton. Neutrons are located out of the nucleus. The incorrect statement is or are. Which is the incorrect statement? Read out all the statements and give the answer. What is the answer? Neutrons have neutral charge. This is true. First part is true. But less mass than that of proton? No. Almost equal. Actually, a slightly bit, more. As bit more. It has, more mass. Okay. Very slight change though. Yeah. Very slight increase. Neutrons have an electric charge. Is this true? No. This is also incorrect. Okay. This is incorrect. This is also incorrect. Next. Neutrons have a neutral charge with almost the same mass as that of proton. This is correct. Neutrons are located out of the nucleus. No, they are inside the nucleus. This is also incorrect. So, which option holds good? They are asking incorrect statements. So, 1, 2 and 4. This is the right answer. Option D is the right answer. Next, which of the following is an electrically neutral particle? Electron, proton, neutron, alpha particles. Which is the right answer? Vignesh says option B. For the previous one? No. It is option D. Okay? It's not B, it's option D. First one is also wrong. For this one, electrically neutral particles. Which are those? Yep. Electron is negatively charged, proton is positively charged, neutron is neutral in nature. What about alpha particles? Alpha particles are nothing but helium nuclei. Helium nuclei means nucleus has protons and neutrons. So, what's going to be the charge? Plus charge. Okay, option C is the right answer. Next, complete the following table. Electron, proton and neutron. Yes, what will be the answer? What is A and what is B? Let's see. So, A is -1. Wrong. A is +1. Yeah, this might be right. What about this one? A is 0. Proton has a charge. This is also wrong. What about this one? Proton has a charge. So, option B is the right answer. A is equal to +1. B is equal to 0. Next, complete the following table. This is done. So as of now, we have discussed about the subatomic particles and their discovery. Okay. So the gas discharge tube experiment is very important. So the only difference between the discovery of electron, that is cathode rays and anode rays, are the experimental setup difference is the perforated cathode. Okay, and in case of cathode rays, the nature of the cathode rays are independent of the gas that is used, but the nature of these anode rays, these are dependent on the nature of the gas that is present in the discharge tube. Okay, electron was discovered by J.J. Thomson. Proton was discovered by Goldstein. Neutron is discovered by James Chadwick. Hi Anoop, hello, welcome to the class Anoop. Yeah, we started like 40 minutes ago. We started at 7 o'clock. How was your day? Moving forward now. Properties, we have discussed it. Symbol of electron, proton and neutron. Nature, electron is negatively charged, protons are positively charged, neutrons are neutral in nature. Relative charge, -1, +1 and 0. Absolute charge, electron, so minus 1.6 into 10 raised to minus 19 coulomb. Proton plus charge, that's it, 1.6 into 10 raised to minus 19 coulomb. Neutron, no charge. Relative mass, electron, the mass of the electron can be neglected, it is negligible. But proton and neutron almost have the same atomic mass, relative mass. Okay, 1 atomic mass unit. Actually, neutron has a slightly more relative mass than that of proton. Next, absolute mass, E by m is nothing but absolute mass. Alright, now we'll move forward with the atomic model, Thomson's model of an atom. Next, we'll discuss Rutherford's model of an atom and Bohr's model of an atom. What do they have to say about all these things? Let's see. Okay, so we'll take 5 minutes break before that. We'll be back in 5 minutes. Alright. right? I'm back again. So let's discuss Thomson's model of an atom. So what does it say? Thomson's model of an atom says, so many scientists proposed various atomic models in order to explain the arrangement of subatomic particles inside an atom. So it was subatomic particles were discovered, but nobody knew how exactly they are arranged in an atom. Okay, because atoms are extremely tiny, subatomic atomic particles are even more tiny, right? So in the year 1903, J.J. Thomson was the first scientist to propose a model for the structure of an atom. So when Thomson proposed his model, neutron was not discovered. So he didn't keep that in mind. He assumed that it's just electron and proton. So we'll postulate something about the structure of an atom. He never kept neutron in his head because neutron was not yet discovered. So Thomson's model of an atom is similar to that of a Christmas cake and watermelon. The way plums and black seeds of watermelon are spread all over the special Christmas cake and red edible part of watermelon. Okay, so you must have eaten watermelon. I just had watermelon. So how does it look? There is a red color flesh, right? So he considered that as the positively charged sphere, inside which the negatively charged particles are randomly spread. Negatively charged particles are nothing but electrons, and the positively charged, he assumed that it is a sphere. This is also called plum pudding. The bread part is the positively charged sphere. The dry fruits or choco chips, this is the negatively charged particles. Okay, so this is nothing but Thomson's model of an atom. It is also called plum pudding model or watermelon model. Okay, according to Thomson's model of an atom consists of a sphere of positive charge with negatively charged electrons embedded in it. Embedding, what do you mean by embed? Stuck. Okay, the positive and negative charges are equal in magnitude, due to which an atom is electrically neutral. So total amount of positive charge is equal to total amount of negative charge. Okay, so this is Thomson's model of an atom. What is the significance then? Thomson's model of atom explained the electrical neutrality nature of the atom. So as proton was also there, and the positive charge was there, negative charge is also there. So he says that an atom is electrically neutral. Present in it, what is it, Tarun? Hi Tarun, welcome to the class. Yeah, Thomson's model of an atom explained the electrical neutrality nature of an atom. So though Thomson's model was able to explain the overall neutrality of atom, it could not explain the result of alpha ray scattering experiment by Rutherford, which led to the discovery of neutrons. So nowhere in Thomson's plum pudding model he mentioned about neutrons. Okay, so yes. This was a drawback, this was a limitation, but it was a great work because he was the first one to come up with a theory. So we'll study this limitation in detail further, but before that we'll study about Rutherford's experiment. Okay, what did Rutherford say? What is the the postulates or the pointers of the theory of Rutherford? Okay, let's see. Hi Kashish, hello, welcome to the class Kashish. Moving on, the first model of an atom was given by Dash, Niels Bohr, Ernst Goldstein, Rutherford, J.J. Thomson. Who was it? Yes? Tell me the answer. Who have passed from 9th standard or 10th standard must be able to give the answer here. Hi Anand Kaushal. Is it D? J.J. Thomson? Absolutely right. Very good. It is option D. Vignesh also very good. Both of you, Anand and Vignesh. It is J.J. Thomson. The Thomson's model of atom, in the Thomson's model of atom, which of the following statements are correct? The mass of the atom is assumed to be uniformly distributed over the atom. The positive charge is assumed to be uniformly distributed over the atom. The electrons are uniformly distributed in the positively charged sphere. The electrons attract each other to stabilize the atom. So, which statements are correct here? Read all the statements and give the answer, please. We have few more students. Hi, Kashish. We are discussing about structure of atom from your 9th grade syllabus. 9th grade syllabus, but in deeper sense. Okay. So we are taking certain concepts out of the syllabus, that is CBSE NCERT syllabus, because this is one of the chapters that is very important for your competitive exams. That's why we are teaching this. Okay. Hi, Tanushri. Hi. Tarun is saying C option. Anand is saying B option. What is the answer? The mass of the atom is assumed to be uniformly distributed over the atom. Did he speak anything about the statement? I mean this. Let's see. The positive charge is assumed to be uniformly distributed over the atom. Yeah, this is true. The electrons are uniformly distributed in the positively charged sphere. Is this true? This is also true. He speaks about that. What about this one? The electrons attract each other and stabilize them? No. So whichever option has fourth one as its option, that is wrong. Right? So this is wrong. We'll eliminate this. We'll eliminate this as well. So this is also true. Okay. So it is first 2 and 3. Okay. Option B is the right answer. Positive charge is assumed to be uniformly distributed over the atom, right? This is the positively charged sphere, the red color. So yes, it is uniformly distributed. He speaks about that. Understood? Moving on. Yes. Watermelon model was proposed by dash, or plum pudding model was proposed by dash. Now I am feeling like eating plum pudding. I had watermelon. Now I want to eat plum pudding. I definitely am a foodie. Yeah, tell me the answer now. Watermelon model was proposed by dash. Niels Bohr, Goldstein, Rutherford, J.J. Thomson. Option C, option D. It is options D. Okay. Anand, Vignesh, Tanushri, all of you very good. Keep it up. Option D is the right answer. Next, Rutherford's model of an atom. This is very, very, very important, guys. Super, super important. Okay. So, in the year 1911, Ernst Rutherford performed alpha particle scattering experiment. This led to the discovery of neutrons as well. So, let us first understand about alpha particle. What is this alpha particle? We all have heard about alpha males. It's quite trending. Sigma male, alpha male, right? So what is this alpha particle then? Does it have anything to do with alpha males? No. So alpha particle, or this is how we represent alpha. Okay. So alpha particles, what are the features? What are the characteristics of them? Positively charged particle having 2 units of positive charge and 4 units of mass, which means that it will have 2 protons and 4 neutrons. Can you think of any element in our periodic table which has this kind of a characteristic? Of course, helium, right? If you remove those 2 electrons, this is if you remove 2 electrons from helium atom, that itself is the alpha particle. Helium nucleus or helium 2 plus. 2 plus means 2 electrons are removed. Okay. So it is emitted by radioactive elements like radium, polonium, placed in the cavity of a block of lead and made into a fine beam with a slit. So how is this bombarded? What is the source? So it will be placed in the lead, lead block, because it is radioactive. These elements are radioactive. They are going to constantly produce helium nuclei. Okay, and will make a fine slit, so that only through the slit that the helium atoms are going to go. Alright, yes, very good, Anand. Yeah. So Rutherford has also used a gold foil in this experiment. Why? What is the reason? See, gold is very malleable. Gold is extremely, extremely malleable. It's the most malleable metal. Okay. So it can be beaten into very thin sheet. So he made use of gold foil because he wanted very thin foils. Okay. What are radioactive elements? So radioactivity is a how can we see that? Okay, let me tell you in very simple definition. Okay, so how do we define radioactivity? There will be some elements which will be constantly producing these other atoms. Okay, smaller atoms from them. That is radioactivity. Okay, so the emission of radiation from the particles constantly, that is radioactivity. Not all the substances are radioactive in nature. There are few elements which are radioactive in nature. Okay, why do they do that? In order to attain stability. So I always tell this in my class. In chemistry, everything is about stability. Okay. Alright, so we were talking about Rutherford's model of an atom. Yes. Rutherford and his students bombarded very thin gold foil with alpha particles, helium nuclei. Okay, a stream of high energy alpha particles from a radioactive source was directed at a thin foil approximately equal to 100 nanometer, very thin gold foil. A thin gold foil had a fluorescent zinc sulfide screen around it. What is it? You are... okay. Can we not talk about anything else apart from the subject, please? Yeah, a stream of high energy alpha particles from a radioactive source was directed at a thin foil of gold metal. Okay, see, this is the lead block inside which there is a radioactive metal. Okay, radioactive element through which the radiations are going to come out in the form of alpha particles, helium nuclei. Okay, so this is the gold foil. So it is bombarded towards that. The helium nuclei is being bombarded towards that. Just like when you throw cricket balls towards the batsman. Okay, or towards a wall. Whenever the alpha particle struck the screen, a tiny flash of light was produced at the point, indicating that so it is passing through the gold foil. Okay, it is passing through the gold foil. Next, Rutherford's model of an atom. So this is the foil. Okay. So what happened? It was assumed that the atom just is a positively charged sphere in which the electrons are embedded like this. It was believed like that. But this experiment proved otherwise. So what were the observations of Rutherford? If this was the case, what would have been the observation? So all the alpha particles, most of the alpha particles would bounce back because it would hit the positively charged sphere and it would bounce back. But this was not the case. The result was ulta. So majority of the alpha particles pass through the gold foil with little or no deflection. They pass through that, which means that the most of the part of the atom is empty. It is shallow. Some alpha particles were deflected from their path and diverged. Okay, alpha particles were deflected. When? Only when they hit something solid, which means that in the center of the atom there is something which has a mass. Okay, so only when the alpha particles hit the center, hit the nucleus which has protons and neutrons, it would show slight deflections or it would bounce back. Okay, so bouncing back was very less. Very few alpha particles are deflected backwards through angles greater than 90 degree. 1 in 12,000 alpha particles. Just 1 in 12,000 alpha particles bounce back. Okay, so what does it indicate? What does it conclude? It indicates the presence of heavy positively charged body. And very few alpha particles deflected backwards through angles greater than 90 degree, which means that it indicates that volume occupied by this heavy positively charged body is very small in comparison to total volume of the atom. So this was experimental evidence. So when we have experimental evidence, we cannot say otherwise, right? So what was the conclusion then? Rutherford's alpha particle scattering experiment shows the presence of nucleus in the atom, and in the nucleus there is something else along with proton. Which is that? That is neutron. So this also gives the following information about the nucleus. It is positively charged, of course, protons are there. It is very dense and hard. It is very small as compared to the size of the atom as a whole. So you can imagine you are in a football field. You are holding a ball. Okay. The size of the ball is the size of the nucleus, and the size of the football field is the size of an atom. So most of the space in the atom is empty. Okay. Rutherford also calculated the radius of the nucleus, which was found to be about 10 to the power of 5 times smaller than the radius of an atom. And when Rutherford put forward his model in the year 1911, even then only electrons and protons were known to be present in the atom. Okay. So even at that time only protons and electrons were discovered, not the nucleus. But this led to the discovery of neutron. Okay, Rutherford model was improved later on by including neutrons in the nucleus. So we will study this improved model of atom now. Alright, so yes. What is the doubt? Tanu, what is your doubt, beta? Tell me. What is the doubt, Tanushri? The alpha particles reflected where the nucleus is present, in those particles are also reflected when the electrons. I don't understand. What is it? The alpha particles reflected where the nucleus is present. Yes, it deflected, it bounced back actually when the alpha particles hit the center of the atom. Yes, that's true. Are also reflected when there is electrons. I don't understand. No. So electrons doesn't have a significant mass. Tanu, electrons doesn't have a significant mass, right? It's not heavy. Okay, so electrons are revolving around the nucleus. So it's very unlikely that the alpha particle would hit the electron. And electrons are very light in weight. Okay, so when you when you bump into somebody who is like 2 years old, what would happen to you? Would you bounce back? Would you fall back? No, right? Why? Because the 1-year-old doesn't have significant mass. He or she is very small. But when you bump into a bodybuilder, what would you do? You would bounce back, right? Same thing. Protons have a significant mass. The nucleus has a significant mass because of proton and neutron. Electrons do not have a significant mass. That's why. Okay, very good, Tanushree. It's a very good question. I'm really impressed. Yeah, it's a very good thing that you have doubts. You should ask doubts. Only then you will be able to understand the concepts. Yeah, you will bounce back. Absolutely. See, you already know the answer. This is a very basic principle. Okay. So the symmetry is not there for your syllabus. For 9th and 10th graders, symmetry is not there. Okay. So yes, Rutherford's model of an atom on the basis of alpha particle scattering experiment, Rutherford gave the nuclear model of an atom. So he came up with the word nucleon. Okay, nucleus. So what will be there in the nucleus? Protons and neutrons will be there. Okay. Today you brought your NTSE guide and you started preparing. That's very good. Very good. But as of now, focus on your final exam for 9th grade. Okay. Right after you finish that, you can start preparing for NTSE, NSTSE, KVPY and everything. Okay. Kickstart your preparation. Now, if it's good for you, do it. Otherwise, it's going to be too much for you. You already have an exam in like 5 days, right? That's why. But it's a good thing that you are focused. Very good. Not everybody is like that. And also make sure to take breaks, Tanu. It is going to drain you out. So as much as you study, it is very important that you take breaks as well. Okay? Yes. So what are we discussing about now? Rutherford's model of an atom. So on the basis of alpha particle scattering experiment, Rutherford gave the nuclear model of an atom. Okay, so an atom consists of positively charged nucleus containing all the protons and neutrons. So entire mass of an atom is concentrated in the nucleus because the mass of the electron is negligible. That is why. Okay, it is negligible. So nucleus is surrounded by electrons and they revolve around the nucleus in well-defined orbits. Nucleus is surrounded by the electrons, which means that this is an electron and the electron is revolving around the nucleus. Nucleus has protons and neutrons. Protons is positively charged, neutrons are neutral. So obviously the nucleus will have positive charge. Okay, so an atom is electrically neutral. So number of protons is equal to number of electrons. Number of protons is equal to number of electrons. Next, what are the drawbacks of Thomson's atomic model? It also has drawbacks. Okay, it is not perfect. So if Thomson's atomic model was correct, then in Rutherford's experiment, alpha particle should be deflected by the subatomic particle present in gold atoms every time. Right? So if Thomson's atomic model, we'll discuss about drawbacks of Rutherford's experiment as well. Okay, but it's about J.J. Thomson now. So how the Rutherford's experiment disregarded certain points of Thomson's atomic model. So if Thomson was correct, so almost all the alpha particles would have been deflected, would have been bounced back. It would hit the positively charged sphere and it would bounce back. But this didn't happen. Only very few alpha particles bounced back. Also, it was not expected to see such large angle deflections since the mass of alpha particles were heavier than protons. Thus, result of Rutherford's experiment could not be explained by Thomson's atomic model. Okay, so what is this? The crystal system without any element of symmetry is triclinic. It is triclinic. Okay, this is not there in your 9th or 10th grade syllabus. Don't worry about it. You will be studying that in detail in your 11th grade. Okay. Yeah. So drawbacks of Rutherford's atomic model. Major drawback was that it could not explain the stability of an atom. He didn't mention anywhere. That how an atom is a stable substance. Substance as in how atom has stability. According to electromagnetic theory of Maxwell, this is also something that you will be studying in your higher grades. Okay, if a charged particle undergoes accelerated motion, so if it has acceleration, be it positively charged particle or negatively charged particle, if it has acceleration, that it must give out some energy, it must radiate some energy. Okay, it means electrons revolving around nucleus will lose energy. So when you are running, so you are running. What will happen? After some time, you are going to collapse if you are not going to eat, or you are going to faint, right? So the same thing happens here. When the energy is radiated continuously, the electron would eventually collapse into the nucleus. But this doesn't happen in atom because atom is stable. If this has been the case, nothing would exist. Everything would have been very unstable. Okay, so another serious drawback of the Rutherford's model that it says nothing about distribution of electrons around the nucleus and the energies of these electrons. It has never mentioned about electrons. The Rutherford only talks about neutrons, right? Yes, he only talks about neutrons, but nothing about where is electron, how is it distributed around the nucleus, nothing. Okay. The unit of electron is U. Proton is also U. The neutron is also U. What is U? Okay, U is atomic mass unit. Tanu. U or AMU we call it. Okay, it is atomic mass unit. Atomic mass unit. Atoms are extremely small, right? We cannot use kg or grams or milligrams. We cannot measure using these. So we have a relative measurement. We are going to compare with carbon 12 atom. Okay, one atomic mass is mass unit is equal to 1/12 mass of carbon 12 atom. This is one atomic mass unit. So when you go to fruit vendor, now everybody has electronic machine, right? But back when I was when I was small, they used to have this kg kallu. In Kannada we call it kallu stone. Okay, they would use that to weigh the fruits or vegetables. They would keep that kallu, that stone, and they would weigh the fruits accordingly. The same thing. This is like the kg stone. Okay, this is the standard. So we are going to compare this. That's why it's called relative mass. Understood? What is PO and RA in radioactivity? Okay, PO is polonium. It is an element. It is a radioactive element. Okay, polonium. RA is radon. Okay, radon. No. It is radium. Sorry, radon is Rn. It is radium. Radium. Yes. Palm tree milk. Oh, okay. In Kannada, kallu means it is stone. Okay. Yeah. Hmm. Let's move on. You have understood, right? PO is polonium. It is a radioactive element. Radon. It is radium is also a radioactive element. Ra for radium, Rn for radon. Ra for radium, Rn for radon. Even uranium is radioactive in nature. Iodine is radioactive in nature. Even bananas, they show radioactivity. The banana, the fruit that we eat, that also shows radioactivity. Okay. Yes. Now we have questions. Couple of questions. I need all of you to answer this. Answer these questions. When alpha particles are sent through a thin metal foil, most of them go straight through the foil because dash. Are you there in Diksha Vedantu community? What do you mean by that? I work for Diksha Vedantu channel. What is community? I don't understand. Yeah, tell me the answer. Alpha particles are much heavier than electrons. Alpha particles positively charged. Most part of the atom is empty space. Alpha particles move with high velocity. Telegram. Yeah. I'm there. Yes, I am there. Of course, I'm there. Why are you typing like that, Tanu? TELEGRAM. Okay. Anand is saying option D. Is this option D? Let's see. Second and third. Let's see. So alpha particles are sent through thin foil. Most of them go straight through the foil because why? Alpha particles are much heavier than electrons. Alpha particles are positively charged. Most of the part of the atom is empty. Yes, this is right. Alpha particles move with high velocity. What is correct? Option A is correct. 1 and 3 is right. Alpha particles are much heavier than electrons. Absolutely right. Alpha particles has 2 protons and 4 2 protons and 2 neutrons. 2 neutrons. Of course, they are heavier than electrons. Next, most of the part in the atom is empty space. This is also right. Okay. Option A is the right answer. Anand. What is my idea? I'll check and tell you tomorrow, Tanu. Okay. I'll check and tell you tomorrow. I'll tell you tomorrow, okay? I'll not forget. I mean, not tomorrow, but on Monday. Moving on. Yeah. Rutherford's alpha particle scattering experiment eventually led to the conclusion that dash. B, ma'am, but why not D option? Why not D option? Let's see. Second and third. Alpha particles are positively charged. Yes, this is true. Okay, but this is not the reason for them to pass through the foil. Okay, this is not the reason for them to pass through the foil. So alpha particles are much heavier than electrons. That's why they could pass through the foil. Because if electrons were heavier than alpha particles, the alpha particles would bounce back. That's why. And most of the atom is empty space. That's absolutely true. They're asking why alpha particles, passed through the foil. What is the reason? Not because alpha particles are positively charged. They are heavy, and the particle, the space in the atom is empty. Okay. This one. Rutherford's alpha particle scattering experiment eventually led to the conclusion that dash. Mass and energy are related. Neutrons are buried deep in the nucleus. Point of impact with matter can be precisely determined. Electrons occupy space around the nucleus. What's the answer? Yeah. Tell me. Option B. Is it option B? What about others? Is it option B? Neutrons are buried deep in the nucleus. Eventually led to the conclusion. Is that it? No, it is option D. Electron occupies space around the nucleus. Okay. He mentioned about the neutrons. Okay. But he did not say that it is buried deep inside the nucleus. He said that nucleus occupies the center part of the atom. Okay, so it eventually led to the conclusion that electrons are occupying the space around the nucleus, and they are revolving around the nucleus in circular orbits. Okay, buried means, how do you say, burying something, burying the dead body, burying a plant. That's burying. Okay, I can't think of any synonyms. I'll check. Precise. Precise means accurate. Okay. Accurate. Precise means. Next. Rutherford's experiment, which established the nuclear model of the atom, used a beam of dash beta particles, gamma rays. This is beta. This is called beta symbol. Okay, beta particles. This is gamma. This is how we write it, gamma. Next, helium atoms, helium nuclei. Is it burn? No, not burning. Burying. Burying. Not burning. Bury means hide or conceal. Sink. Option D is the right answer. Helium nuclei. Absolutely right. Very good. So they would confuse you with this question. Okay, it is not helium atoms. It is helium nuclei. We are going to remove 2 electrons from helium atom. Okay, this is helium 2 plus, which means that 2 electrons are removed, which means that helium nuclei it is. It has only protons and neutrons. It doesn't have any electrons. Alright. Next. Yeah, atomic model. So Bohr's atomic model of an atom. This is very, very important. Bohr's atomic model. So Bohr, oh, look at this young scientist. Yes, in order to explain the drawback of Rutherford's model, Niels Bohr in 1913 put forward a model of atom. So Rutherford's model could not explain the stability of the atom, right? So Niels Bohr came up with a theory, came up with a with an atom. So I'll give the break after we discuss Bohr's model of an atom. Tanu, okay? We'll discuss that. I'll give you 10 minutes break so that you can have your food and come back. Yeah. So according to Bohr's model, the electrons could revolve around the nucleus in certain orbits only known as discrete orbits. Okay. So electrons are not randomly revolving around the nucleus. They revolve around the nucleus in specific orbits, in specific paths. Okay. It's called discrete orbits. The discrete orbits are those in which the angular momentum of the electron is a whole number multiple of h by 2 pi. Okay. So this is not so important for you. Okay. So this is not there for your 9th grade. This is there for your 11th grade. So we'll not discuss in detail about this. Alright, you have a doubt. What is it, Anand? Go ahead. Ask your doubt. I'll try to help you out with your doubt if I know. Yeah. So the discrete orbits are those in which the angular momentum, you'll learn about angular momentum and everything in detail. Spin momentum. There are so many things. Okay. As of now, don't worry about this so much. Okay, you'll be learning about that in your 11th grade. We will be teaching you that. We'll be giving you a heads up about all these things. So, yeah, these circular orbits or shells are called energy levels or energy shells. And these are represented in two ways. They can be represented either by letters or by using numbers. Okay, or numbers. So, each energy level is associated with fixed amount of energy. It has a fixed amount of energy. Discrete orbits have fixed amount of energy. K is the nearest energy level to the nucleus. Next L, M, N, the list goes on. Okay, H is Planck's constant. What is Planck's constant? You will learn that in your higher grade. So what is the difference between atomic model and atomic theory? Which atomic model or theory you are exactly talking about? So atomic model is going to explain the features of the model. Atomic theory is going to give the postulates. There is no significant difference. Okay, both are the same. I have no idea about MCAT. I am sorry, Munwar, but I don't have any idea about MCAT. Nope. Yeah. So this is about the energy levels or energy shells. Okay. So yes, there is no change in the energy of electrons as long as they keep revolving in the same energy level. But if they want to go to the lower energy level or higher energy level, there will be some absorption or radiation of energy. Okay, for example, there is an electron in the K shell. Okay, alright, I'll write like this. This is a K shell. There is an electron which is revolving around the nucleus in K shell. If it wants to go to the next shell, L shell, so it is going to absorb the energy. Suppose there is a electron in M shell, KLM, okay, third energy level. So this electron wants to go to a K shell or L shell. It is coming down. Okay, then it is going to lose the energy. Okay, absorbing and losing. Yeah, according to Bohr's model, the change in energy takes place only when an electron jumps from one energy level to another. Okay, and when an electron jumps from lower energy level to higher energy level, the electron absorbs energy, and when an electron jumps from higher to lower energy level, the electron is going to lose energy. Okay, yeah. So energy absorbed is called absorption, energy emitted is called emission. You're most welcome, Munwar. Please don't spam the chat box, please. Yeah. According to Bohr's model, the amount of energy absorbed or emitted is given by the difference of energies. Okay, delta is equal to h nu. So this is also something that you will be studying in your higher grade. Planck's constant, it is Planck's constant. Okay, it has a value. It has a value also. Okay, it is 6.626 into 10 raised to minus 34 joule. Just like you have, what is that? Avogadro number. That's a constant, right? Just like that, Planck's constant is also a constant. Explaining the atoms or the elements which have only one electron. Okay, but what is the limitation? It could not explain the line spectra of multi-electron atoms. So this atom could not explain these orbitals or subshells, shells for higher atoms, higher elements, which has more than one electron. It could not explain the multi-electron line spectra of multi-electron atoms. It does not explain the splitting of lines in the magnetic field. Okay, so this is also something that you will be learning in your higher grade, grade 11. Okay, so if you are if you are studying in 9th or 10th, do not worry about this. Okay, even for your Olympiad exams, this will not come. Only if you are studying in 11th and 12th, this is important for your competitive exams, NEET, JEE. Okay, so we'll be taking a separate class for that as well. I'll be giving you some giving you some basic information about all these things. Okay, we'll conduct separate foundation classes for 11th as well as 12th. Understood? Yes. Moving on, Rutherford's model of an atom could not explain its stability. This was overcome by another atomic model. The postulates of the new model of atom are dash. What is it? It is option B, 2 and 3. Okay, each shell or orbit corresponds to a definite energy. Yes, they have the electrons revolve in discrete energy levels. Therefore, these circular shells are known as energy shells. As long as electron revolve in the stationary orbit, it neither radiates nor absorbs energy. Only when it jumps from one energy level to another, it's going to lose or gain energy. Okay, next. An electron jumps from an orbit P to Q and loses energy. The same electron, it's option B. Very good, Anand. Absolutely right. Next question. An electron jumps from an orbit P to Q and loses energy. Loses energy means emission is happening. Okay, emission is happening. The same electron when jumps from R to Q gains energy. R to Q, jumps from R to Q. Okay, gains energy. Okay, so P to Q loses energy. The increasing order of distance of these orbits from the nucleus is. So this is the nucleus. I will give you a hint. This is the nucleus. This is R. This is Q. This is P. So what will be the answer? When will be the... We will meet in next live. Okay, we'll do that. Bye-bye. Unwar. I would say stay and listen to the whole class, but yeah, I would understand. Option A, P, Q, R. It's option D. It's the otherwise, right? What are they asking? Increasing order of distance. Increasing order means which is nearest, they're asking. Then the farthest. Okay? It's option D. Option D is the right answer. Not A, it's option D. Option D is the right answer. Next, what is the wavelength of radiation whose frequency is 2 into 10 raised to 14 per second? So this is not there in your syllabus as of now. Okay, don't worry about it. So now let's summarize what are the models that we have discussed. Okay, so Thomson's model of an atom, we have discussed it. And then we have discussed Rutherford's model of an atom and Bohr's model of an atom. So these are the postulates of the respective model. Okay, you can go through this. I'll be attaching these notes in the next class. And in the description, you can check this out. I have attached the notes of the previous previous class. I really hope I have. Yes, I have. Alright. Yeah. Let's move on then. We'll discuss about atomic number, mass number, and isotopes and applications, isobars, isotopes, and isodiapers as well. Okay. But before that, we'll take a small break of 10 minutes. We'll be back in 10 minutes. Okay. Don't go anywhere. Go have something to eat and come back. Even I'm going to do the same thing. Alright, I'm back, guys. Let's discuss atomic number and mass number. Just give me a second. Yeah. So what is atomic number and mass number? So atomic number is the number of protons present in an atom. That is atomic number. Okay. And nucleus. So what's going to happen? Nucleus has already neutrons and protons. We call them nucleons. Atomic number of an element is equal to the number of protons in one atom of an element. Okay. So whenever you hear the word atomic number, whenever you hear the term atomic number, remember this. So what is atomic number? It is the number of protons present in an atom. And it is denoted by the symbol Z. Not A but Z. Okay. For a neutral atom, the number of electrons will be equal to the number of protons, which is equal to atomic number. Hi fitness tips. Hello. Next, atomic number of carbon is 6, which means that it has 6 protons. Okay, 6 protons in its nucleus. In neutral atom, number of protons is equal to number of electrons. We can also say that atomic number of an element is equal to the number of electrons in neutral atom of an element. Okay. You're my old student. What's your name? If you remind me the name, I would recall. The atomic number of an element is equal to the number of electrons present only in neutral atom and not in an ion. Okay, ion is either positively charged or negatively charged. Positively charged ions are called, they are called cations. Negatively charged ions are called anions. Anions. Okay, these are negatively charged. So the atomic number doesn't mean that how many electrons are there in the respective ion. No. Okay, ion is formed if an atom loses or gains electron. Okay. Next, atomic number of an element does not change during reaction. It remains the same because only electrons take part in the reaction. Okay, atomic number of an element is not going to change in the reaction because what is going to take part in the reaction? Only the electrons. Only the electrons. Mass number is also very simple. Now, number of protons plus number of neutrons, which means that whatever there is there in the center of an atom is the mass number. Okay, it is represented by A. Atomic number is represented by Z. Mass number is represented by A. So, atomic mass of an element is the number of times an atom of the element is heavier than the hydrogen atom. Okay, so it is represented by atomic mass unit. And positive charge of the nucleus is due to protons. Because in the nucleus, protons are going to be there and neutrons are going to be there. Neutrons do not have any charge. Protons have positive charge. Of course, what will be the charge of the nucleus? It's going to be plus charge. Okay. And as you know, it's the protons and neutrons that make up the mass of an atom and they have a mass of 1 atomic mass unit each. The mass is almost equal, both of their mass. So the atomic masses of elements should have been in whole numbers. But it has been found that some elements have fractional atomic mass. For example, chlorine has the atomic mass of 35.5. What is the reason behind that? How are we going to calculate? This is how we represent an element. On top, under the superscript. Superscript will represent the mass number. Superscript. And at the bottom, at the foot, we are going to represent the atomic number. Okay, so this is called subscript. Super, sub. Sub means at the foot, super at the top, on our head. Yeah. So carbon atom is represented, sulfur atom is represented. For a neutral atom, so atomic number is equal to number of protons is equal to number of electrons. Okay, mass number will be equal to number of protons plus number of neutrons. Okay, how do we calculate number of neutrons then? Mass number minus atomic number. Simple. So here are few of the initial the atoms where we have the chart of symbol, atomic number and mass number. For your high school, I mean if you are in 9th and 10th, it's enough for you to remember first 20 elements. If you are going for your 11th grade, you need to memorize at least 30, up till 30 or 40. Okay, because you have summer holidays now, you will have some time. Please do that. Okay, you have to remember the symbol, atomic number, mass number, as well as valency. Valency is the combining capacity. Along with this, remember valency. Okay, valency. Moving on, the symbol of an element is 4He2. It suggests that an atom of helium contains 2 electrons. An atom of helium contains 4 protons. Helium has an atomic number 4. Helium occurs as a diatomic molecule. The incorrect statement is or are is. How many incorrect statements are there? This represents the mass number, right? Mass number means it is the number of protons plus number of neutrons. It represents the atomic number. It means that the number of protons is mentioned here. So what is the correct answer here? Option D, 2, 3 and 4. Okay, all of these are wrong. As this is a neutral atom, so we can say that it has 2 electrons because 2 protons are there. This is a neutral atom, so it has 2 electrons. Okay, but apart from that statement, all the other are wrong. An atom of helium contains 4 protons. No 4 protons, just 2 protons and 2 neutrons. Okay, 2 neutrons. And helium has atomic number 4. No, it is the mass number 4. Helium occurs as a diatomic molecule. No, it is a monoatomic molecule. Monoatomic it is, not diatomic. Okay, next. An atom of sodium has an atomic number of 11 and a mass number of 23. Which of the following statements is correct? Vignesh, good. Option D was the right answer for the previous one. What about this one? Atomic number is 11, which means that the number of protons is 11. So mass number is 23, which means that proton plus neutrons are 23. Okay, number of protons is 11. Protons plus neutron is 23, which means that proton, how many protons will be there? 11 plus n is equal to 23. N is equal to 23 minus 11, 12. Okay, so tell me the answer. An atom of sodium has 11 protons, 11 electrons and 11 neutrons. Wrong. It should be 12 neutrons. Let's eliminate. An atom of sodium has 11 protons, 12 electrons and 11 neutrons. No, this is electrically neutral, so it cannot be this answer. No, wrong. Eliminating. An element of sodium has 11 protons. True. 11 electrons. True. 12 neutrons. Yes, true. Option C is the right answer. You can use elimination method. Next. An atom of phosphorus has atomic number 15 and a mass number of 31. How many neutrons does it contain? Tanushri, option C was the right answer. Very good, Tanushri. Vignesh, not option D, it is option C. Sodium is an electrically neutral atom, which means that number of protons will be equal to number of electrons. What is the answer for this one? How many neutrons does it contain? Atomic number is 15. Mass number is 31. Simple. 31 minus 15. It is 16. Option B is the right answer. Okay. Next. Isotopes and their applications. Isotopes. The atomic masses of some elements are in fractions and not whole numbers. What is the reason behind that? For example, we saw chlorine, right? It is 35.5. Why not 36? Why not 35? We can round figure it, no? No. Why not? And atomic mass of copper is 63.5. Why is it there in the fraction? The fractional atomic mass of elements are due to existence of isotopes having different masses. Then what do you mean by isotopes? Isotopes are the atoms of the same element having same atomic number. They have same atomic number but different mass number. They'll have different mass number. Okay, you can see here the atomic number of chlorine is 17 in both of these isotopes. Okay, but the mass number is different here. For one of the chlorine isotope, it is 35. For another one, 37. So which one should we consider, 35 or 37? So this is the confusion, right? So we are going to do something. What are we going to do? We are going to take the average. How are we going to do that? So abundance in the nature. So isotopes abundance will be detected. Okay, chlorine has two isotopes with abundance 75% and 25%. So which is present in 75%? It is 35 chlorine. 25%, 37 chlorine is present. Okay. So what are we going to do? Even in here, hydrogen has three isotopes, protium, deuterium and tritium. In all these cases, protons, the atomic number is same, it is 1. But the mass number is different here. See mass number, which means that mass number is 1 for the first protium, 2 for the deuterium, 3 for tritium. Okay. Why there is a change in neutron? There occur isotopes. Tanushri, in nature itself, there occur isotopes. Okay. Yeah. So carbon element has three isotopes, carbon 12, carbon 13 and carbon 14. So which one should we consider as a mass? Is it 12, 13 or 14? This is the confusion. So what are the general characteristics of, we'll take the average. So this is how we are going to do it. We'll come to that. But let's discuss the general characteristics of isotopes. They have same chemical properties, but they have different nuclear properties. Why? The nucleus has different number of protons and neutrons in each case of the isotope. That's why. Okay, for example, carbon 14 isotope is radioactive while carbon 12 isotope is non-radioactive. Okay. So applications. The mass of an atom of any natural element is taken as the average mass of all naturally occurring atoms of that element. Okay. So for the element which has no isotope, mass of the atom will be neutron plus proton. Okay. But for an element with isotopes like chlorine, carbon, hydrogen, iodine, uranium, so these have isotopes, right? So what is going to happen? So mass is considered taking the average mass of the isotopes. How we do that? This is how we do that. 35 chlorine exists in 75% in the nature. I'll tell you how. Okay. There are something called isobars and isotones. Okay. So an element cannot have, for example, iron or chlorine. It cannot have different atomic number. It can have different mass. Chlorine, it's always be 17, the atomic number. Only the mass number can vary for isotopes. It can be 37, 35, even for carbon 12. But see here, it's always going to be the same. Atomic number never changes. The number of protons never changes for an element. Okay? Yeah. So these are the atoms of the same element having different atomic mass, not the number. Okay, same atomic number will be there, different mass number they'll have. So the atomic mass of chlorine is 35.5 atomic mass unit. It means that if you take a certain amount of chlorine, it will contain both isotopes of chlorine and the average mass will be 35.5 atomic mass unit. Okay. Next, cobalt isotope is used to remove brain tumors and in treatment of certain types of cancer. Gamma radiations emitted by cobalt 60. So in radiation therapy, they use it. Cobalt is used, cobalt 60. Next, iodine isotope is used in used to determine the activity of thyroid gland, and also it is used in treatment of goiter. These are the uses of isotopes. Iodine 131 is used. What will you cover in part 2? There are so many things to cover in part 2, Tanushree. Okay, we'll discuss that in the next class. Uranium isotope is used in nuclear reactors to produce nuclear energy. When uranium-235 atoms are bombarded with neutrons, uranium nuclei break up to form. I already covered, covered for CBSE or state board syllabus for your final exams, but not for foundation courses. Okay, we'll cover that. So basically remember this, uranium isotopes is used in nuclear reactors to produce nuclear energy. It is radioactive in nature. Now consider this. Consider the following graph of percentage abundance versus mass of lead. The relative atomic mass of lead is dash. So yeah, tell me the answer. 23.6%. Which lead is that? That is lead PB. So 206. Okay. 207 lead exist in nature. How much? 22.6%. 208 lead exist. Oh, it has the most percentage, 53.8%. Take the average. Bombarding means okay, so not giving the gap. Okay, bombarding means forcing, pushing. Okay, if I say that Vignesh, I'm bombarding you with questions, means that I'm asking repeated questions. Okay, I'm not even giving you time to answer. I'm bombarding you with a lot of questions. That is bombarding. Okay. Tell me the answer. Calculate this. Attacking. Bombarding means attacking. What will be the answer? Option C is the right answer. 207.301. How to do this? See, a percentage abundance is given. Multiplying that by the atomic mass, the respective atomic mass, then dividing by 100 plus taking the average. Okay, do this. Option C is the right answer. Vignesh, very good. Keep it up. You're very quick. You must be really good in maths then. Next question. The sum of the number of neutrons and protons in one of the isotope of hydrogen is dash. 6, 5, 4, 3. The number of neutrons and protons, which means that mass number they are saying. Mass number. Protium has mass number 1. I'll tell you here. Protium has mass number 1. Okay. Deuterium has 2. Tritium has 3. Yeah, very good. Tanushri and Vignesh, absolutely right. It is option D. Very good. Keep it up. Next. Which of the following statements about the isotopes of an element is not correct? Isotopes have the same proton number. Isotopes have the same chemical properties. Isotopes have the same nucleon number. Atoms of the isotopes of an element have the same number of electrons. What's the answer? Option C. Isotopes have the same nucleon number. Nucleon means proton and neutron, which means that it is mass number, right? Mass number, right? Yeah, which is not correct. Option C is not correct. Absolutely right. Very good. All of the other statements are absolutely right about isotopes. They have the same proton number. Yes, atomic number is same. Isotopes have the same chemical properties. It is also correct. But isotopes do not have same nuclear number. Nucleons are nothing but protons plus neutrons. Next. Yes, isobars, isotones and isodiaphers. Okay, and isoelectronic species. For you, for high schoolers, even in your competitive exams, so isobars and isotopes will be asked. Isodiaphers, isoelectronic species, they wouldn't ask you. Okay, yes, isobars. The word isobar is taken from the Greek word isos, which means that equal, and baris means heavy. Okay, so these are the atoms of different elements. Isotopes are the atoms of the same element. These are the atoms of different elements. Tanushri, isotopes are different, isobars are different, isotones are different. All of them are different. Okay, yeah. So atoms of different elements having different atomic numbers but the same mass number are called isobars. For example, argon, see here, 40 is its mass number, 18 is the atomic number. And then we have another element, potassium. Its atomic mass is also 40, but atomic number is 19, but mass number is equal to argon. Okay, and calcium, mass number is similar to argon and potassium, but the atomic number is 20 here. So these are the atoms of atoms of different elements having different atomic numbers but same mass number. Okay. So here are some examples. See the number of neutrons there. The number of neutrons differ here. Isobars have different atomic number, which means number of electrons are different and hence their chemical properties are also different. In case of isotopes, the chemical properties are same, but in case of isobars, the chemical properties are not same. They have different chemical properties. And then we have some other examples, boron and carbon. See there. What is it? These are isotones. What are isotones? They have same number of neutrons but different atomic and mass number. See the atomic number in case of boron and carbon. Boron has 5 as its atomic number, 6 as its atomic number for carbon. 12 is the mass number of boron, 13 is the mass number of carbon. But if you calculate the number of neutrons, it is the same. So isotones have the same number of neutrons. You know how I remember this? Tone. So tone, neutron. This is how I remember. Number of neutrons will be same. Okay. Yes. You can take down the examples. So let's not discuss isodiapers and isoelectronic species. It's going to be too much for you. Okay. We'll discuss that while we are studying for 11th grade. The atoms having same value of difference between neutrons and protons are called dash. Isotones or isodiapers? It is isodiapers. Okay. So you'll be learning that in your higher grades or in upcoming sessions. Now, as of now, please comprehend this. Try to comprehend this and try to, practice more and more questions. We'll be giving you week quiz as well. Okay. We'll conduct week quiz. Option B, yeah, option B is the right answer, Vignesh. How did you know? We didn't even talk about isodiapers. But very good. Yeah, which page shows isobars here? Isobars are the atoms of different element having same mass number but different atomic number. This is not isobars, this is isotopes. What will be the answer? D. Both B and C are the right answer. Okay. Next, which of the following is an isodiapers? Don't want this. So as of now, what did we discuss? We have discussed about atomic number, mass number, and isotopes, isobars, and isotones. Okay. Yeah. And then, yeah, we'll discuss Maxwell electromagnetic wave theory, black body radiation, line spectrum of hydrogen while we are discussing grade 11. Okay. For today, this is it. Okay. So this is very important: atomic number, mass number, atomic mass unit, and atomic theories, Dalton's atomic theory, and we have Rutherford's experiment and J.J. Thomson experiment, plum pudding model or watermelon model. Okay. So revise this thoroughly. Alpha scattering experiment is also super important. Revise this thoroughly. I'll give you the notes right away. Okay. Right away as in on Monday. On Monday's class, we'll give the notes. Okay. Until then, take good care of yourself. Thank you so much for joining me today. Bye-bye guys. It's already 9:20. So we have Neha ma'am taking the class. Watch her live entirely because it's very important, physics. And physics, I used to find it very difficult. Neha ma'am teaches really well. So watch her class. Okay. And then sleep off. Revise and sleep off. Okay. Bye-bye. Have a good night everyone. Thank you so much. Tata.